So on the previous lesson, we learned that an isosceles triangle has at least two congruent sides. So today we're going to learn a little bit more about isosceles and equilateral triangle and how to use their properties to help us set up equations, solve for x, and plug it back in to find measurements. So when an isosceles triangle has exactly two congruent sides, then the two sides are the legs. So basically, let's look over here and we'll make this an isosceles triangle. So what it's saying is that when you have an isosceles triangle with only two legs, exactly two sides are congruent, that these are referred to as the legs. Next, the angle that is formed by the two legs. So if you look at this leg and they form an angle right here, this is referred to as the vertex angle. The third side that we haven't talked about yet, all right, the third side is the base of the isosceles triangle. All right, so this side is the base. All right, the two angles that are adjacent to the base are called the base angles. So those are right here. So this angle here and this angle here, those are our base angles. And remember again, so that's this angle and that one. So two angles adjacent to the base. So remember that word again, adjacent means next to, touching, all right, it's sharing something, has something in common with the base. So these are the base angles. Here, up here, this guy here, this is the vertex angle. So these are all very important words to know. We've got to make sure you know all the parts of the isosceles triangle. The legs, the vertex angle here, this is the base. And another important thing to remember about when something is referred to as the base, not necessarily mean it's the bottom, because you can also have an isosceles triangle that may be what we would call upside down. And if we have the two congruent sides here, so these would be the legs and this would be the base. So basically, you really need to think of base as the side that is not congruent to another piece. So now what we're going to do is take this and apply it to help us solve and find set up equations. So if two sides of a triangle are congruent, all right, so we know, okay, that's isosceles, then the angles opposite of them are also congruent. So if the sides are congruent, then the angles are congruent. So let's kind of label this triangle over here, and we'll just give it some vertices, A, B, and C. And we're going to say, okay, I want to make it an isosceles. So two sides are congruent. So what this whole theorem, this base angles theorem, is telling us is that if these sides are congruent, then the angles opposite of them are also congruent to one another. So this base angle is going to be congruent to this base angle. So if the sides are congruent to one another, then the angles are going to be congruent to each other as well. So basically, if side AB is congruent to side BC, then angle A is congruent to angle C. And that's how we use isosceles triangles. Again, if the sides are congruent, then the angles across from them, opposite them, are also congruent. Now the converse to the base angle theorem, and again, this word converse basically just means is that we're switching the if and then. We're switching the order. So this was our previous if-then up here where we said if AB is congruent to BC, then angle A is congruent to angle C. So this was the original if-then. So converse means we're going to switch the order of these two things. So now we're going to say if two angles of a triangle are congruent, then the sides opposite of them are congruent. So basically, if you have the angles congruent, you have the sides congruent, and vice versa. If you have the sides congruent, then you have the angles. So let's label our triangle again. A, B, C. Let's make an isosceles because exactly two are the same. Let's not do that. We've got to do the converse. So the converse says if two angles are congruent, so if I have these two angles, now I can say that the sides are congruent, opposite of them. So this side here, and if I take that angle, go opposite of it, this side is the same. So basically, if we're going to take the converse now, angle A is congruent to angle C, then side AB congruent to BC. Simple stuff. If you have the sides, you have the angles. If you have the angles, you have the sides. Now, the corollary to the base angle theorem. Remember, again, we've talked about this word corollary. It just means something that naturally follows. So kind of something you're going like, well, duh, that makes sense. That's a corollary, naturally follows. And I've briefly mentioned this to you before, but if a triangle is equilateral, then it is also equiangular. So if you have all of the sides, then you can go ahead and it is okay to make the conclusion that then all of the angles are the same exact measure. So the corollary to that of the converse, the corollary to the converse is we switch those things around and say if it's equiangular, so if you have it's equiangular, then you can say it's equilateral. So basically, once you have one of these situations, you have the other. If you have the sides, you can also conclude then the angles are congruent. If you know the angles are congruent, you can conclude that the sides are congruent. Kind of like here in the isosceles, if you have the angles congruent, then you can conclude the sides. If the sides, then the angles. So let's look at some examples to how we use the properties of isosceles and equilateral triangles. So we're going to find the missing measurement. So in this triangle here, what you need to notice is that, okay, these red marks, that means all the angles are the same measure. Well, we just learned that if you have all the angles, then that also means you have all of the sides are the same measure. So if this side is 12, then all of the sides are 12. So here is the converse of that. We're given the sides are all congruent. So if the sides are congruent, we can safely say that the angles are all congruent. And we briefly talked about this when we did triangle sum, that if all of these angles are the same, so basically you have three angles here, and they're all adding up to 180. So anytime, see, we have it split evenly into three pieces, so that means each one is 60 degrees. So every equilateral, equiangular triangle, this is the measurement of all the angles, all the time, every single time, if it's equiangular. Here we have find the value of x and y. This, what we need to recognize here is that these sides are the same measure. Well, we've learned that in an isosceles triangle, if the sides are the same, that means these angles are the same measure. So basically, remember everything inside of this triangle, all of these angles must add up to 180 degrees every time. Well, we have 102 that's already taken up out of that big angle there. So if we subtract that out, we have 78 left. Well, 78 is for both of these angles that are the exact same measure. So just like we did here, we divided by 3 when there were 3 equal pieces. Now we have 2 equal pieces, so we're going to divide by 2. So each piece here is 39. So x is 39 and y is also 39. All right, here, pretty similar too. Notice we have an isosceles triangle, so if you have the sides are congruent, then the angles are the same. So basically, what you have here, you notice that you have a right triangle here. A right isosceles triangle is what we refer to as a 45, 45, 90 triangle, because this angle is 90. So think about it. We have 180 total. 90 is already taken up by the right angle, so 90 is left. If it's isosceles, that means this sum is split evenly between 2 angles. So that equals 45. So here x is 45. Then actually to find y, we would have to take that 9y. 9y equals 45, divide by 9, divide by 9. So y is 5. And the last one, drawing and diagrams. A base angle in an isosceles triangle measures 37 degrees. So draw and label the triangle. So we're going to draw a triangle. We're going to make it isosceles. It tells me that a base angle is 37 degrees. Well, what we just learned is that if these sides are the same, then the angles are the same. So if this one's 37, this one's 37. So the question here then, what is the measure of the vertex angle? So this is why these are kind of the questions that you're going to see about isosceles triangle, where you have to be able to know which angle it is referring to. Again, these are referred to as the base angles. Here and here, because these are the legs, these are the legs. The angle formed by the 2 legs is the vertex angle. So it's asking us for this angle up here. Well, we already determined, since it's isosceles, if the legs are the same, the base angles are the same. So we have 180 in every triangle. We're taking out one base angle. We're taking out the other base angle. So that's taking out 74. So if we take out 74, what's left is 106 degrees. So our vertex angle is 106 degrees. Now, my picture doesn't necessarily represent that, but remember, I drew my own picture. As long as my measurement matches all of the sum, then we're good to go.